Okay, here we go. Okay. All right, so after my commercial, all right, so let's do a quick 30-second just review of what we've done so far. For the guys who are the first time here for the CCNP switch, and for the guys who have been following the switching meetups. So pretty much a lot of the stuff that we went through was beginning just GNS3 and the switching, its limitations, how to set up a Cisco Access server or a terminal server with your 2500 series. We did that. The different trunking methods. So we went through the different ways that we can form a trunk. VTP, we really go through too much through VTP because I think the general consensus was that we know it already. We don't want to spend time on it, so we just skip that. We also went through the locking down the VLANs. So pretty much protected ports, your PVLANs, your VACLs, or your VLAN access lists, and the MACLs, or your MAC address access lists we went over. And last meetup, we actually took a pretty deep, we took our time and we took a pretty deep look at the Ether channels, your PACP and your LACP. So that was pretty nice. And actually, I'm looking to actually get myself a Dell Power Connect switch, just so I can probably in a future meetup. One of my goals is to get more other industries out there, like say like a Dell or Brocade switches or Juniper switches. So when it comes down for putting these meetups together, one of my goals is for us to kind of get more real world. I mean, one of the things that I do when I teach the Cisco classes is I feel like they leave so much out. I mean, it's great because, I mean, granted, it's a Cisco class, so, you know, it's going to be pretty much biased to Cisco stuff, but it doesn't really fully train you for the real world. As much as we may not like it, you know, we walk into a shop and not everything's Cisco. You're going to have some Dells, Brocades, Junipers, like I mentioned before, out there. So I think it's important for us to actually see these things in the real world. So I'm actually looking at a few eBay auctions. I think it's like there's a Power Connect that I'm looking at that's about 80 bucks. Lets me do LLDP for my CDP neighbor stuff, and it lets me do LACP too. So I know Jim had a question before about the Ether channels between like an ABC vendor and Dell and a Cisco. So where I was working there, I couldn't find any non-Cisco switches that I could test it out with. So I will definitely put that together. Maybe I'll make like a quick maybe YouTube video or something about that. So that'll be pretty nice to do. Okay, so for tonight's agenda, and when I was putting together this PowerPoint here over the weekend, I'm thinking as much as I would like to say we can finish all this tonight, I don't think we are. So I think my guesstimate is we'll probably get this much done, I think. Or at least, definitely spanning tree will get done, and maybe HSRP and the track command that we'll get done here for tonight. It's just that spanning tree, there's just so much there is to do with it, and between the explanations, between the labs, you know, it may be a little bit more than 2 hours. One of my things is I kind of like to keep this around 2 hours. One, my voice kind of goes, and two, you know, unless we're face to face, I'm sure you guys kind of doze off after 2 hours. The retention is only so much you guys can keep track. So we're gonna cut this around, like I said, 2 hours. So like 9:15, 9:30ish, we'll kill this meeting for tonight. But that's what I was mentioning. We'll probably have another part 2, or I'll just make part 3 or whatever for the first hop stuff. So that's pretty much the goal here for tonight. Okay. So for tonight's topology, now, how many of you guys actually have real gear with you at home right now? Real switches, something kind of like, this is kind of what I have right now at home for my real gear. Do you guys have any switches set up at home on your ends? Or does nobody know? Okay. Okay, awesome. So Jeff's going for the HSRP stuff, which is going to be pretty nice. Cornelius got one switch. Jim's got... Okay. Well, one of the things that's what I was actually talking to Mark the other day about this. One thing that I feel that's kind of essential, especially when you're doing the switching stuff or anything network related, it's the good thing is, like, you know what, switches are pretty cheap nowadays. I mean, this whole setup that we're looking at here, um, the 35 the 3560s and the 2950s. I mean, they're well, maybe not the 3560s. Those are kind of like a little bit on the higher end, but 2950s are pretty relatively cheap. You can pretty much get these switches for 50 to 100 bucks a piece. The 3560s are a little bit on the higher end. I think they're maybe 200 or 300 bucks, especially if you're going for the PoE. But I mean, pretty much, I mean, this is relatively a good investment for anybody who's really looking to like sink their teeth into this. One of the things I always say is just repetition over and over and over. You know, see it from me, see it for yourself, see it from another meetup group, and just after a while, it just sinks in. So by no means, I'm not a smart guy. One of the reasons I like to put these meetups together is because it helps, you know, refresh my memory, and at the same time too, you know, help you guys maybe find some little things here and there that you may have not known before. But if you do have the gear at home, I would strongly encourage you guys, put together a setup similar to this. Just get yourself 3 switches, connect them. Right now I just got ports, you know, FA0101. I just kind of have them connected like this. So once we actually get into the spanning tree and take a look at the toolkit, aka the nerd knobs, you know, this way we could, you guys actually see for yourselves on your end instead of just kind of watching me. I like to kind of call it active learning. You know, as you guys do it, you guys kind of remember it better. So unfortunately, as we saw in the previous meetups, we didn't really have a GNS3 is really not a good way to work when we have CCNP switch or any kind of layer 2 topics. So definitely, you know, if you do get the chance, you know, make the investment, you know, buy a couple switches and go for that. So so pretty much get the gear, make up your own topology, get your active learning going, so this way you better remember things. Now, and I did mention this briefly during the first meetup, but the main differences between or at least the switches that I have here, the 2950 and the 3560s. The 2950 is going to be your cheapest model that you could pretty much get, that you could use to study for your CCNA or CCNP. Like I mentioned, it's about maybe like 50 to 100 bucks. Same deal with the 3550. I think that one lets you do layer 3 switching, so you can say like IP routing to enable like IP route and router rip and all that kind of stuff. So these are kind of like a little bit on the cheaper end. So if you, I mean, it all depends on your goals. If you guys are just looking to go for CCNA and, you know, a little bit of MP and you're done, then, you know, by all means, just stay on the low end area. But if you guys are looking to go for a CCNP plus, then I would say, you know, you might have to cough up a couple more dollars to get your 3560s, which let you do PV LANs. And PV LANs we did a few meetups ago. We saw that, and there was a white paper as well, that the PV LANs are only available on the 3560s and not on the lower end models here. So really depends on what you're looking to do, what your budget is. But like I said, if you can, you know, go for the 3560s. And also for the router models, and the reason I bring this up is because we're going to see if we can tackle some HSRP, VRP stuff here for tonight. The 2600s, these are going to be your really low-end routers here. You could do HSRP as well, but they're kind of getting really old. I think those are the same line as the 2950s and 3550s. You're looking at about maybe 50 to 100 bucks each, probably for like a 2600 11XM or something. So they're pretty affordable. But if you want to go a little bit higher end model, and this once again depends on what career you kind of want to go down with. The 2800s are the replacement for the 2600s. And the good thing with the 2800s, they let you do, well, actually the 26 could do it too, but 28s are a lot faster hardware-wise. And if you're looking to do voice, like CCNA voice over IP, the 2800s are hardware-wise quicker. So when I was doing voice about a year or so ago, I got myself a few 2800s. And if you really have the money, you can get the new ISR models, which is the 2900s. But these are kind of pricey. Like, these are what most companies kind of use today if they're buying a like an ISR, like small branch router. So if you want the happy medium, I would say, you know, go for these guys right here. Rumor is that the CCNA, not CCNA, the CCIE is going to actually revamp meaning that they're gonna release a new version of the CCIE lab, routing and switching. So I don't know if the 26 will kind of do it for you at that point. I'm not sure what they're gonna really change with, but I guess to be on the safe side, just in terms of not buying equipment multiple times, you can pretty much go with the 2800 model. So. Cornelia said, "Can I use Packet Tracer for this lab?" Yeah, you might be able to. I just don't know for sure because I don't really have experience using Packet Tracer. I've always either used GNS3 or real equipment, so I can't really say if things will work or not on it. And Jim says, "Free Cisco Switch Lab." Let me see this right here. We got a little link down here in the chat window. Let me pull this guy in here. Yes, I haven't seen this site before here, but this looks. So Switch Lab is free, open to the entire world. Okay, so it looks like somebody's is looking. We're gonna probably see here a free rack here. So if you guys want to take advantage of it, definitely go for that. Okay. Okay, so let's get into the meat here for tonight. So the different flavors of spanning tree that we have here. So now this is of course one of the things, as I always say, that this is something that usually it's already in place for the most part when you walk into an environment. So you really don't have too much of a. Sometimes people don't really have too much experience with spanning tree, and it's not that people aren't smart or they just don't get these things. It's just that you barely use these things. I mean, it's for the most part, most companies who walk in, spanning trees automatically turned on for you on a switch anyway. So you're not really going to have too much of a, go in there, configure, or troubleshoot. I mean, it's usually kind of like a once a blue, maybe once in a while you kind of touch it. So obviously, that tends for people to forget things. So, but once you get down to it, just like anything else, it's not really that bad. So first up, just for historical purposes, the original version of spanning tree, which is 802.1d, which pretty much the purpose behind that was we're just going to have one spanning tree instance for the entire switch. So whether you have, 10, 20, 30 VLANs, you're just going to have one spanning tree instance, or in this case, let's say like I have my diagram over here. Let's say this port here would be blocked. Let's pick him. So that link over here between port 1 and port 1 over here will be completely blocked, and no traffic will be going over that. So, I mean, at the time, I think it was like in the 70s that the protocol came out. Was pretty good for the time, but obviously as demands and the resources got more and more higher for this, it wasn't too feasible to kind of have this one link being down only for the whole entire topology here. So, as Cisco normally does with a lot of their a lot of the technologies that come out, they usually make up their own flavor or their own version of stuff. So Cisco came out with the flavor called based on the 802.1d protocol, and they called it per VLAN spanning tree plus. So one tip to know when you're looking at the different versions of spanning tree is whenever you see a plus, that usually means that that this is going to be a Cisco flavor or a Cisco proprietary version of spanning tree. So if you look down here, jumping a little bit ahead, per VLAN spanning tree, you got a plus. That's basically going to be the rapid spanning tree flavor, but the Cisco version of that. So that's one thing you can kind of take a look at when you're looking at the pluses here. But the big enhancement with the PVST plus was that even though you still have that 802.1d instance, which we'll take a look at the different port roles and all that kind of stuff in a bit, but pretty much the only difference is here that we're going to have the ability we'll have one single instance for every VLAN. So versus your regular common spanning tree or CST, now we're going to actually have the chance to actually make multiple instances for, let's say, your 10, 20 VLANs on here. Another flavor of spanning tree that we have is your MST, which will also take into look in a little bit of the configuration of this and the the ways we can slice and dice this. It's also called 802.1s, and basically I mean, sometimes you see this in companies and sometimes you don't, but the idea behind this is that in order to lower hardware resources, we're gonna basically group VLANs into one spanning tree instance. So instead of having, let's say I had 10 VLANs and I'm gonna put them in 10 different spanning tree instances, maybe you could break it up 50-50. Maybe I could say I could have two spanning tree instances, and I'm gonna put 5 VLANs in one instance and 5 VLANs in another instance. So this way, my switch is not gonna have to work as hard when it comes time to convergence or they basically the BPDUs and whatnot, because I only have one, or in this case two, MST or spanning tree instances, even though I have 10 VLANs. So we'll take a look at that later on as well, and the configuration for it as for this too. So later down, the industry did come out with a improvement to 802.1d, which we're going to be adding some roles and port forwardings, which we'll see in a bit, and enhancing the BPDU exchanges, which we'll see a little bit more down. I have a slide for that, but basically this one's going to be called your Rapid Spanning Tree Protocol, or 802.1w. Hey Osai, how's it going? Osai, hopefully I pronounced the name right. So pretty much over here we have our 802.1w, and that's pretty much, as you can see here, we have no plus, so that's not going to be your, there's going to be, that's render neutral. You can pretty much pop that into any switch that you want. So that's that guy, and as I mentioned, a little bit earlier, per VLAN spanning tree plus, which is going to be basically the Cisco flavor of rapid spanning tree, which this introduces a couple things here, like your uplink fast and your backbone fast, and it's basically going to be their version of 1W, but Cisco, as usual, they like to make up their own protocol, and they throw in extra bells and whistles into the protocol to kind of I guess make people biased and be like, hey, let's buy the Cisco version because or the hardware, because their software comes with ABC features. So also one good site that I want to point out too, there's a little chart here that's actually pretty helpful, and let me just drag this in here. Packet Life. So I'm sure you guys have seen this site a bunch of times. If not, this is a pretty good resource here for just documents and blogs and whatnot. But if you go down to the library and the cheat sheet section, and this is not just for spanning tree, if you go down here, there's a bunch of different other cheat sheets here that you can take a look at. It's just like a really quick look for different protocols and whatnot here. But if we jump down to the spanning tree, you could pretty much see the same thing that I just highlighted in the slide, but obviously much more information here. So if you guys want to take a look at that, we'll post that into the chat here real quick, and you guys can take a look at that later on after the webinar. Okay. So now this is the part 2 where we get to the different components or the different parts of spanning tree. Now, as you can see here, a lot of this you may or may not have seen before, but once again, since this is kind of like a thing that we don't see on we don't do all the time, we tend to forget. So here's just a quick list of the different parts and the different terminology that we have when we deal with spanning tree. And before I go through this list here, let me just backtrack one slide. The reason I have a little asterisk here is because at least the models that I have of the switches, so my 2950 and my 3560s, this is probably just because the original 802.1d just phased out. I only have the chance, of course, I get my PVST Plus and my per VLAN rapid spanning tree here, and my MST or 802.1s. The one with the asterisk, pretty much that my switches support. Which, I mean, for the most part, when you go out in the real world, you're probably either going to see If no one's configured the switch out of the box or made any changes to the default, it's going to be in the PVST. Or if somebody's been proactive and try to modify a spanning tree, they'll probably change it to the Cisco flavor of the per VLAN rapid spanning tree. Or if they want to really, if they have a lot of VLANs, like say you're for like a service provider or something, you may see MST, and you may see MST on a switch. But out of the box, for the most part, the switch is basically going to be in your PVST mode. So that's the reason I have those asterisks there, is because that's currently what we're going to take a look at here for tonight when we actually do some of the configuration here for the switches. Okay, so going back to my my components over here. So the way that we actually form or find out, like let's say on my layer 2 topology, one of the first things that we have to do when we look at this, I'm sure I'm not going to ask the question, but the whole purpose behind trans spanning tree is, of course, that we want to break. We have a sorry guys. I have a layer 2 topology. In this case, I have my 3 switches, and of course, we want redundancy, or we want multiple ways of getting around my network. So it wouldn't make sense for me to not have a cable between port 1 and port 1 on my switches here. Because of course the name of the game in IT is always redundancy. You always want at least 1 or 2 different ways to get to your destination, or you want to make sure that if you have a link failure, and this is not just in networking, this is across the board and almost. I mean, I can only speak for server admins because I used to be working in that. You know, you could take a look at layer 1 stuff like hard drives. You'll have like a RAID setup to make sure that you don't lose any data, or you know, you'll have spare power supplies just in case one dies out. I mean, the same concept kind of applies here for layer 2 stuff. So right here, but the only, well, right here we have, and if you have something kind of similar set up like this at home, or if you have Packet Tracer, Cornelius, you can kind of put this here together here. The only issue that we have here, though, is that we're going to have loops, or we have more than one ways of getting to, let's say I have a network all for this guy here, or a server all for here, let's say. Now, if somebody's coming from the 2950, which kind of going back to your routing protocols, which way would I take? Would I go out of port 1, or would I go off of port 2? Oh, thanks. So in order to kind of make things easier, as having just a one direction to get to this server guy down here, spanning tree is basically gonna block one of these ports, and like I said, I could say this guy down here, block him, so this way I could always force the traffic and be predictable, and go down port number 2. So in theory, it sounds very simple, but looking at this, looking at my little terminology list over here, there's a lot of pieces that, of course, fall into that. So the first thing is cost of a link. So every single link that we have on our switches, whether it be Ethernet, fast Ethernet, gig Ethernet, or fiber, there's going to be a cost associated with each port. And one of the things that we can do is, maybe if you take a look at a switch, and let me do that right now. I'll go to P5. That's going to be my 2950. I'll just show spanning tree, just basic simple right now by itself. So I can take a look here right now, and each port here, I have a cost associated with it. So right now I got 2 fast Ethernet ports right now in my spanning tree, and the cost is actually 19 for each. And usually the name with the game with spanning tree is that the lower is going to be better, or lower is going to be more desirable. Kind of going back to our admin distances, or admin distance chart, the lower the AD or the metric of a protocol, the more desirable or more reliable that it's going to be. Same thing here with our spanning tree. So if we actually take a look at the Cisco site, and let me just put my Google in here real quick. Spanning tree port cost, let's say. And actually, Packet Life comes back here again to save us. So pretty much here, depending on the link, the speed of the link. So for example, my fast Ethernet, which is going to be your my FA ports, my 100 megabits per second, the default value is going to be 19 here, or the way they have it here is recommended value. But of course, the smaller you go, so for example, my 1 gigabit is going to be 4, my 10 gigabit is going to be 2. Unfortunately, I don't have any gig ports on my lab switch here, so I can't show you guys anything different, but you could actually modify this as well if you like. But generally, it's always easier just to kind of leave it at the default. So for the most part, we're just going to be seeing 19 here. But the cost is going to be taken into consideration when getting to the root bridge. So that's one good link there if you just do a quick Google search for that. But now, going back to the concept of the root bridge. Now, the reason that they call this the root bridge is because back when we didn't have switches, we just had bridges, or basically hubs, like kind of dumb switches or dumb hubs, or I guess you could say the prerequisite, or the bridge that was about to become the switch when this technology came out. So if you guys kind of get confused with the term bridge, like root bridge, just call it root switch, if anything. Pretty much the same exact concept. So whenever you see anything with bridge related, so going back here to my show spanning tree, bridge ID, just say switch ID, or what's the ID of my switch here. So you can kind of use that to kind of better memorize the terminology. But the idea behind the root bridge is that the person with the lowest MAC address or lowest priority, and I'll get into priority in a second, will become I guess you say the central point of focus for my switching environment, or my layer 2 environment to get to. So meaning, let's say, I don't know, I'm just picking like a random switcher. So let's say this guy right here, my 3560, if he's the root, and right now, of course, in my lab topology here, there's not much going on here. I only have 2 switches. But let's say in a normal environment, of course, there could be potentially dozens or hundreds of switches. For that particular instance, or that a spanning tree instance, all my switches are going to look for the fastest way to get to that root port. So basically, they're going to be using the cost of the links to actually get to that root bridge. Remember we said before, lower is better. So we're going to find the lowest hops, or you can say pluses or additions to get to the root bridge, and that link on the whole switch. So like I said, in this case, I don't have 2 ports here, but let's say, of course, me going down port 2 is the quickest way, and let's say these are all fast Ethernet interfaces. So if going down here over through port 2, this is a cost of 19, cost of 19, cost of 19. So 19 plus 19, I think it's like 30 or something, 40, is going to be, of course, higher than going through just one jump of 19. So my switch here, my 2950 is going to prefer the lowest path, or the lowest cost, to get to the root bridge here. So if you think about it, it's kind of similar to our IGPs, or interior gateway protocols. We're looking for the quickest or shortest path to get to our destination. And in this case, our destination is going to be our root switch, or our root bridge. So, so that's that. And another terminology that we have with our spanning tree is going to be your system extended ID, which we can kind of see here, our sys ID extension, or extension number here. Basically, the idea behind this, and this kind of ties in here with our BPDUs. BPDUs, or I forget what they stand for off the top of my head, but basically the BPDUs is the frames that get sent out throughout my layer 2 topology, which contain the system extension ID, or the priority and the VLAN number. So if you take a look here out of the box, Bridgeport data unit. Yeah, you're probably that sounds about right, Jim. Yeah, thanks for that. So basically, over here, my BPDU is going to consist of 2 main portions: the MAC address and the system ID. Or, I mean, and you guys can correct me if I'm wrong on this, but the system ID is basically just the VLAN number by default out of the box. I believe this is something that you could change. So as we can see here right now, I only got 1 VLAN on this on the switch. If I do a show VLAN B, this is a brand new out of the box. I haven't really done anything with it. So my first VLAN here, the system ID extension is going to be 1, or because this is basically spanning VLAN number 1 here. So if I do, let me create VLAN 10, let's say. Okay, so I create another VLAN. I just called it VLAN 10. And notice down here, my system extension, or my system ID, has been changed to 10. So out of the box, by default, if you don't change anything, the priority, and once again, I'm kind of jumping back and forth, but this is where all the kind of terminology sometimes gets a little confusing. But it's the priority down here. And actually, let me just cross these guys out, so this way I kind of know what I've gone over. By default, every BPDU is going to have a default priority of 32,768. So not sure why they picked that number. That was just the random number that they picked. So the idea behind it, once again, we're saying lower is better. When we're sending out these BPDUs to find who's going to be the root or the central focus point of our layer 2 topology, every switch out of the box is going to start with this number here. And in order to have different instances or different spanning tree instances to kind of differentiate between one over the other, we're going to use the system extension, the system ID extension, to have multiple VLAN instances. So this way, all the switches that are on VLAN 10 could have the same or the similar number here. So here's your priority, 32,778, which is basically the priority number plus the system ID here, or the VLAN number. So that's how you get that number down here. So that's that with that guy. Priority I mentioned already, and MAC address. So another thing with the BPDUs, the MAC address of the switch is also important for this because along with the system extend ID, we're going to use our MAC address to form our BPDU portion, so or frame. So right here we can take a look, and let me just say no. Let me get rid of this guy. All right. So let me go back to my VLAN 1 over here, and I can see here just by taking a look at this particular instance here, and I just did a show spanning tree over here. This is my root ID, or this is basically my my BPDU information here. So here's my priority, here's my MAC address, and this is kind of pretty obvious here. It says this bridge is the root, so I know that out of my topology over here, my 2950 is going to be the root. So I probably should have circled over here 38560. This will be the root here. Okay. So in this simple topology here, I can pretty much say that port 1 over here going up, and let me just erase some of this stuff over here. Get rid of this guy. It's a lot easier if I had a whiteboard in front of me, but okay. So the port's going upstream. Now, and if you guys have messed around a little bit with MPLS terminology, they kind of use the same terminology here. The ports want to go upstream or up to the root bridge here, or the root switch here. So if I jump down to, and there's something called DP ports, I believe, which we can actually verify in a second here. DP ports going up to the root bridge, or I think they're root ports actually, RP. Root ports going up to the root bridge. So let me jump to one of my other switches here, and I'll go to P3 for that. Okay, so in this particular, my 3560, we've been using him for a while for the past few meetups, so he's got a couple more VLANs than the other guys, but in this case here, so once again, I got my port 1, and my port 3, which in my case I got port 1 going up to the root. Port 3 is going to the non-PoE 3560. I can see here what my BPDU information is over here. And notice here, I'm not seeing that this bridge is that line here that I saw before of saying that this switch is the root, because in this case it's not. We're actually using the 2950 is going to be the root here in this case. So if I take a look at the actual the cost here, 19, and that's like a number that you probably will memorize after a while. A lot of shops have a lot of fast Ethernet ports, so you'll probably see 19 multiple times. So if you guys are going for the test and you see 19, you can just pretty much think, okay, that's going to equal my fast Ethernet interface. But you notice here the role of that port, of port number 1 here. So as I said, that's the RP root port. And the role of that port is going to be root, saying that that's basically the, and this is only going to be 1 per switch. Only 1 port on the switch is going to be, or at least per instance, is going to be facing its root port, the root bridge, and only 1 port on that whole switch can be called root. So that's in this case, the way we have it set up here, root is going to be pointing to port 1, going up to the root bridge, and I got my alternate port over here, which is kind of like my backup port, or my second best port to get to the root bridge. And going back to my topology here, I can see that is the case because in this case I got my classic 3 switches all connected to each other. Of course, if my link here between 1 and 1 go out, of course the only other way that I can get to my root bridge will be going throughout a port 3. So in this case it's being blocked because I don't want a loop or basically one logical topology here. So that's almost as if, let me see here. It's like this link doesn't even exist right now. So there's one logical topology, or one way to get from this switch over here out to the other end of the network here, being my regular 3560 switch on this end over here. So of course, as you guys could imagine, if I pull out this cable, go into the root, this one will kick in. But we'll do that in a bit though. But I want to keep on going with the terminology here. This MAC address, BPDUs, and by the way, guys, I'm kind of really going quick with the terminology here because I'm assuming that you guys know some of this stuff already. So I'm kind of doing a flyby of this. Here we go, port states and the port roles. Let me go through these here real quick. The port role, as we can see here, you'll see once again doing your show spanning tree command here. You'll have certain roles for the ports that you have. So in my example right here, I got 2 right now. One's called root and one's called alternate. And as we mentioned before, the root is the best way to get to my root bridge, and alternate port is kind of like my backup port to get to the root bridge. And the port state is going to be, okay, you know, the port role is kind of, all right, nice. That's kind of like a fancy name of what's it doing. But in reality, is if we want to know that, is this forwarding, or is this blocking, or is it learning, or is it listening? What is this port actually doing here? That's where the state will come into play, this little column over here. So right now, of course, my root port being the best port to get to the root bridge is going to be forwarding. Forwarding is basically the way that I am forwarding frames, and it's open right now. So this link here between 3560 PoE and my 2950 is open. This communication here is not being blocked right now. But as you can kind of see with my port number 3, the alternative port, or kind of like my backup port, that port is currently being blocked right now. So that's why, going back to my picture over here, I can kind of see it's kind of like empty right now. So nothing will be forwarded out that port. It's effectively blocked on that end. So something interesting too that we could take a look at here, we could take a look at the 3560 and see what the state of this port is, port number 3 on this end, and see if we get the same thing. If we see block on that end, so I can write down here, he's block, he's forward. Now let me put the port state. So this is root, and you are alternate. Okay, so let me jump to the 2950. That's 5. Oops. Okay, so right now here's my root bridge. Now, let me take a look at the ports I have here. So here, we saw before on the 3560 PoE, we saw the roles were forward and alternate, right? In this case here, I don't see any of those roles. I see the 2 ports set as designated. So one thing to take also note, and where's my little eraser? Okay. Anything from the root switches point of view is going to be always forwarding, because I'm like basically the king in town. My port state is I'm the root, so anything on the root bridge never gets blocked. All my ports are forwarding at this point. So when we see this here, we're basically saying that anything going downstream to my, I guess you could say, inferior switches or my lower switches is going to be set as a DP port or a designated port. So this will be here DP for designated port. And designated ports are always going to be going, like I said, downstream or down to my inferior switches or the inferior BPDUs that I've heard on that link. And of course, I'm going to be forwarding. I'll put FW because I want to remove my number 1. DP forwarding. Okay. So anytime, and going upstream, we have root or RP ports. So root here also going to be, sometimes they call it like RP or for root port. And this here, I'm just taking a stab here. This is probably the same thing. I'm going to be forwarding. It'll be my root or my RP port or my root port. So let me take a look at that guy over there. Let me go to my regular 3560. He is P4. I'll do show spanning tree for VLAN 1. And by the way, since I have a couple of VLANs on here, you can kind of see I got 1, I got 100, I got 200 here. So if I want to take a look at that 1 instance, once again, abuse the question mark, use that thing. I can use the VLAN command here and say, what VLAN do you want to take a look at? So in this case, I just want to see 1. And notice that there's no more, press, enter or press space to keep on going. It just shows me VLAN, the VLAN 1 instance of spanning tree, and that's it. You're done. So in this case here, let's see here. I got my BPD information here, the information of the bridge. So one good thing about spanning tree is that it kind of tells you the full picture no matter what switch you're on. So it'll tell you, what my BPDU information for my switch is right now, the bridge ID, or the basically the who's the real or who is the root bridge in this case, and this is his information here. So but let's take a look at the port statuses down here. So the roles, pretty much a mirror copy of my PoE switch that I showed earlier. My root port is going upstream to the root bridge, so of course it's going to be a forwarding state, and the role is going to be root. And the role is basically a helpful way to know which, if you don't have a network diagram and you're just doing spanning tree, or say you're at work and you're mapping out the layer 2 topology in Visio or Paint or whatever it is, the role is a helpful way to find out what direction or what direction is the fastest way I can get to my root bridge. So it's kind of like a little trail, and this is something that guys you should probably actually do depending on how big your environment is. Find out before you have a loop happening or weird things start to happen on your network and you're not sure what the cause could be, and sometimes it may or may not be a spanning tree issue. Find out beforehand, and one of the things for troubleshooting is always find out who is the root bridge to begin with. So if you kind of know that information ahead of time, you don't have to go to all these switches and start doing, show spanning tree to find out who is the root bridge. You could also already have a little layer 2 topology already set up to know who's the root bridge already. And of course, you can go through all your switches one by one, or you can pretty much use this information, this section here, for this particular instance to see who is the root bridge for this particular VLAN instance. Okay. Okay, so pretty much for port 2 for my 3560, I pretty much knew that port 2 is going to be my RP port because it's upstream to the root. But let's take a look at port 3. Is port 3 a mirror copy? And I'm seeing here it's a DP port or a designated port. That's the role. So before we saw this as alternate on the PoE switch, and it was set to block in this case. So we're seeing a little bit different output over here actually. So this is set to DP and it's forwarding. Okay, so from the 3560 point of view, it looks like it's forwarding, but from the PoE switch point of view, it's actually blocking. So one thing to take note is when you're mapping out your topology, sometimes, or at least I did when I first started learning spanning tree, I thought this link over here between port 3 and port 3, I thought the whole link was gone. I thought like this whole link on both ends would say block block, but in reality, it's only one side of the switch is actually blocking, while the other port looks like it's forwarding. But the thing is, it's kind of going to forward to a dead end, so it's not really going to go anywhere. But that's one thing to actually take note of when you're first learning this, because this, at least I did. There was a kind of, I guess, my misconception. I don't know if you guys had the same thing where you thought that the whole line was down. So, and I think the way that it chooses that which port to block on both ends is once again the lower is better. So in this case, I gotta take a look at my two MAC addresses here, and I can see which one is the lowest MAC address. And if the MAC address, I believe the MAC address or the priority is the same, or there's some kind of tiebreaker right there, they'll use the lowest port number. And I believe the lowest port number is blocked. I'll have to double check that, but I believe that's how kind of like how the theory goes. If the BPDU is the same, the lowest port will be put into the block state. So I don't know if you guys can pretty much confirm me on that one, but I think that's the methodology around that. Okay. Okay, and DP port. So notice here too, I mean, when we take a look at designated is generally when we're going downstream. So if I take a look at my topology here again, root, I'm going down, or my DP port, I'm going downstream. And if I take a look at this here from the 3560 point of view, I'm also going downstream. I'm going down to the 3560. So in this case, if I just took a quick look, the 2950 has the lowest MAC address. The 3560 probably has a second to lowest MAC address, and the 3560 PoE has the doesn't have the best one because I'm going down to him. So I can kind of confirm that and see if that's the case or not. So let me. My paint's not here. Okay, so let's try doing that. So VLAN 1. This is my bridge ID here. So let me just copy him in here. Okay, let me go to my, oops, that was this one here. Okay, let me go to my 2950. That is P5. Oops. Okay, so this is his MAC address here. And notice here, it says here, this bridge is the root. Notice that the MAC addresses here match. Okay, and the priority matches as well too. I got 32,769, and on this priority here for myself, for the BPD information for my particular switch here, I do see the same exact priority here. So you can kind of, aside from the fact that it says in plain English, this is the root, you can verify it also by looking at this information here as well. So let's do copy that. Put them there. Oh wait, this is the same here. Hold on. Where did I mess up on? 3560. Nope. Okay, so I think I had backwards. Sorry guys. This is actually the bridge ID information for the root bridge, and this is my BPD information. So I had it flip-flopped. Okay. So this is the MAC address for this particular switch. Let me put this in here. Okay, and let me go to my PoE switch. That's port 3. Okay, PoE switch, let me do a show spanning. That's his information. Here we go. Okay. So if the books are right, then technically the root bridge should have the lowest MAC address here. So I'm seeing here the first portion here. I'm seeing for the root bridge, I'm seeing 0. Seeing here 000C. So starting from left to right, I'm taking a look at the first 4 digits or characters here. 000 beats out 001 and 001. So that, right there shows us that that's the root bridge. That's how it won. Let me take a look. Okay, so let's take a look at these 2 bottom switches down here. So I got 0013 and 0015. So, of course, 0013 is lower than 0015. So that would explain why the regular 3560 is superior, or the BPDUs will be higher than the 0015. So once again, the name of the game with spanning tree is lower is better. So the lower MAC address will win in this case. That's why port number 3 on the 3560 is pointing downstream to the inferior switch, or to the inferior BPDU being the PoE switch. So that's why in that case the blocking port will be on the lower MAC address in the instance here. Okay, so does that help clear up some information, guys, or do you want me to kind of go into anything else here? Okay, cool. Okay. All right, so we went through the DP ports, which is going downstream. Root port is basically going to be the switches pointing to the best, pointing to the switch that's the root bridge, and there's only 1 per switch. Alternate port and backup ports are pretty much the same thing. Basically, they're the port that gets blocked, or the backup port to get to the root bridge, and in case the main one goes offline. And the different states here. So this is you could say these are the roles. So I can put here roles. So this is kind of help to kind of differentiate between the roles and the states. So in this case, we took a look at all the roles. But for the states here, we already took a look at the forwarding state, which is pretty self-explanatory. I'm forwarding frames. Blocking state, I am not forwarding frames. But we're seeing 2 states down here, 3 states down here that we haven't seen yet. So, and we're not actually going to see it at this point because nothing's changing our topology here. These switches are not coming up. They're not learning anything, so we're not going to see that at this point. But one of the takeaways here, and I'm not going to get into the details about the timers and that kind of stuff. I'm kind of assuming you guys already saw that information already. But when a switch boots up, it's going to go through a few states. I believe listening is the first state, which is, and if you guys remember from your study material, I think it's like 20 or 15 seconds or something like that. Learning goes through another 10 to 20 second timer until it finally gets to the forwarding state. And like I said, I mean, I'm assuming we already kind of have that background a little bit, so I'm not going to go into the specifics with that. But basically, that's the kind of states that we go through, that the ports go through to learn and hear the BPDUs, and from there calculate who's going to be the DP port, who's going to be the RP port, and who's going to be blocking between that potential 30 to 60-second waiting time. Okay, one question. Regardless with the switches using fiber uplinks, is it the same roles? I would imagine so. I haven't actually looked at that before. I don't have fiber in my lab here, but I could take a look at one of my switches at work, and which they got fiber. I can see if that's a case or not. I would say 95% sure that yes. I don't think there will be any other states saying otherwise. Yeah. All right, thanks, Jeff. Yeah, I would think so, because if there was any other different states or roles, I would think that the books, or the CCNP would tell us if that was the case or not. Okay, so a few other notes here I kind of went over already. Not gonna go through this right now. A couple with the span tree commands. So a couple of common commands here that we can use for spanning tree, and we're not even getting into the nerd knobs yet or to the toolkit. We're just looking at basic spanning tree. Like I mentioned, out of the box, it's already enabled for us. One thing that we can take a look at to see what version or what mode a spanning tree that we're running. I just basically do a show spanning tree again. And right here at the top of each instance, you're going to see spanning tree is enabled, protocol IEEE. Now, I don't know why they call this, and you guys can correct me if I'm wrong, IEEE. That's basically going to be your PVST plus out of the box. I don't know why they call it IEEE, but bare bones out of the box, if you don't change spanning tree, it's going to be this mode here. So, and one way I can verify that, if I just do a show run, towards the top, I mean, you don't have to go too far down. You can see here, spanning tree mode is PVST. I mean, they don't have the plus there, but that's this right here. So I don't know why. It's kind of a little contradictory, because it's a Cisco proprietary version, but they call it here when you, where was that? I'll just issue it again. They call it IEEE, but it's really not. It's just regular PVST plus. But if you want to go ahead and change that mode, I can do that globally here. So let me do a spanning tree. Question mark. And actually, even before that, let me just do a regular question mark here and see what we get here. Okay, so we can enable some backbone fast, loop guard, uplink fast. I'm not going to get MST, multiple spanning tree. I'm not going to get into that right now. We'll get into that in a bit. This is pretty interesting. I think this is where you can change up the method. Let's see what we have here. I gotta look into that. I haven't played with that command yet, but mode, we'll say. And as I mentioned before, I already took a look at the different modes that my switches have here. In this case, I can only run 3 different flavors. As I mentioned, out of the box, it's already configured for PVST. Preferably rapid PVST. Long story short, pretty much the rapid is a faster convergence. I think it cuts down like by 30 seconds or something like that. The listening and learning and all the states that it takes for a switch to finally go into the forwarding role. The rapid is a quicker way to go through that states instead of using the regular PVST, because of course remember the PVST is Cisco's flavor of the original 802.1d. So you rather use, if possible, rapid, which is going to be based off the industry standard rapid spanning tree, or 802.1w. But the only, I guess if you say negative, the only negative into enabling rapid PBST is it's a little bit more resource intensive because I ran into an issue one time where a service provider basically maxed out the CPU usage because we had so many VLANs and because we were using the spanning tree, of course, there was so many different VLAN instances that every time there was like a pull of a cable or whatever, the CPU would spike on the 6500. So that's why the only thing I can say about the negative with the Rapid is that it's a little bit more resource intensive. So I guess you could say one good thing that you could do is take a look at the CPU of your switch. Of course, in this case, my switch here in the lab is probably like 5–10%, if anything. But in the real world, you could take a look at that and just make sure that whatever you're running currently, if converting to Rapid, it will actually not, overload your switch. And of course, here I have my MST, which is your multiple spanning tree. That's your 802.1D, 802.1S, which we'll see a little bit later tonight. Okay, so that's how we change that. Spanning tree VLAN X root primary. So this is basically going to be the command here that we use, and I guess you say its sister command is secondary. When we actually want to do load balancing, or I guess you call it load balancing, or fully utilizing links. So remember originally we had this setup here where if port, or let's say in this case, port number 3 here is blocking. Now for VLAN 1, because that's what we were looking at right now, we were just looking at VLAN 1. Right now for VLAN 1, that link is not being utilized right now because we have it set to blocking. Now, what we can do is for a particular VLAN, so I can hard code the root for a particular switch. Let's say, for example, let's do it on this guy right here. So let's say spanning tree VLAN, and let's say what I got here, 10. I'll say 100. I think I have 100 on here already. We could change some timers here. This is how we can change the priority of the switch if we want to change it from the default of the VLAN number. But here's a nice command here called root, which is basically going to be the way that I say, okay, I'm hard coding you to be the root. Pretty much ignore the MAC address, the system ID, all that kind of stuff. I'm just hard coding you to be the root bridge for a switch, which is pretty much best practice. A lot of people do that anyway. Hitting my question mark here again, and I can see here I got my primary and my secondary here. So if I wanted this switch, my PoE switch, to be the primary for VLAN 1, so I'm gonna remove it from the 2950 because it's an older switch. Probably that's why it has a lower MAC address, and give it to my PoE switch for whatever reason. Let's say I want to give it to him. Let's hit enter. So let's see what happens to my spanning tree instance here. Okay, so I said 100. I'll look at that one exactly. Okay, so notice now for spanning tree 200. I think they say 100 or 200. 100. Let me do it for 1. Let's keep it consistent here. Spanning tree, who was that? VLAN X. Root primary. Okay, so here we caught it in mid-action. So now pretty much that I changed up the topology to the layer 2 topology. I'm seeing the role change from listening. It's learning right now. And eventually it should be forwarding. Okay, still learning. So this is that whole timers, and I don't know off the top of my head what the timers are. I know they're between 20–30 seconds, give or take some, but forwarding. Here we go. So here are the states that we saw earlier before that we couldn't see because nothing was happening with our layer 2 topology. So right now I got my learning state. Oh, where was I? Listening. So that's whenever there was a change, whether there was, like I said, there was a failure in layer 2 topology, or I plugged another trunk in, or I added a new switch into the topology, what have you. or in this case, we're kind of forced it to happen by me hard coding who's going to be the root bridge. So the final, I guess, after the dust has settled here, so now we're seeing that the PoE switch is going to be my root bridge. So right now my MAC address is kind of, that whole, theory that we were saying that, okay, so the person with the lowest MAC address is the one who becomes the root. That kind of goes thrown out the window because I'm hard coding that PoE switch to be my root bridge. So going with that same theory, what we saw before, the roles kind of changed up here. So now I should see that everything's going downstream now. So I'm going to see these DP ports going out of the PoE switch and everything's forwarding. So as we see my DP ports going downstream to my inferior switches, everything's forwarding here. And of course, secondary will be my way of hard coding who's going to be the second root bridge in case the primary one goes down. And this is more for like design. If you want to hard code who's going to be primary, who's going to be secondary, which is pretty much highly recommended. This would be the commands to actually do that. And of course, as I mentioned before, the commands here, which I should probably have put in the slides. This is where you would actually change the default timers. So by default, out of the box, I got my hello, max age, and my forwarding delay timers over here. So this is where I will go ahead and actually change that if I want to modify that from the defaults. And of course, if you can see here, that's on a per VLAN instance. And same thing with the priority. So all these are per VLAN instances. We're not using the original 802.1d. So we're not going to have to worry about, one VLAN for one instance for all. So we're going to have to specify that if we want to change that up. Okay, and here we go, something for the port priority. So as I kind of showed it already up here, priority. Actually, what's port priority? Let me see that. I got that from one of the white papers. Let me try that out. Just out of curiosity here. Spanning tree, VLAN 1. Okay, nice. So here we go. This is a. Let me try to update this actually. So, cost. So this is. Let me put this in here actually because it's actually pretty good. So this is going to be the interface level. Because remember, the cost is going to be the cost of the link. My fast Ethernet is going to be 19. And let me squeeze this over here. Spanning tree, VLAN 1, cost X output. And I think I have port priority. Yeah, I have port priority in there already. Okay. So once again, guys, it's something that we don't... I don't do it on a daily basis, so I forget all these commands and stuff, and I really rely on the white papers for this stuff too. So, okay. So here's where we can change the cost for that link, which is another way that we can customize and optimize our spanning tree or layer 2 topology here. So we can say cost, question mark, and instead of saying that, and once again, lower is better, so I can say something like, I don't know, let's say 10. That'll also change up our spanning tree topology here. So let me go to VLAN 1. And notice here that I went under the 0-1 interface and I changed them up to cost of 10. Because I manually hard-coded what the cost of that will be. So if you did want to change it up, that will be the place to do it. Okay. I don't know why did I put this here. This is a little bit too early. So this is the config that we're going to do for our multiple spanning tree topology here, but we're going to do this in a bit here. So one thing too that I want to point out. So one thing is, right now I personally have these 3 switches here, and I know that pretty much these flavors, the PVST, the PVRST is the only switch flavors of spanning tree that are allowed on my switches. But one thing that you could do if you go to the Cisco site, and let me do Cisco.com. If you go to the, and what do I call it, the product navigator, I think feature navigator. Here we go. And this doesn't just apply to a spanning tree. I mean, pretty much any feature that you're looking for in the iOS or Nexus or whatever you're looking for. You can see if before you even download the image, you can actually take a look and see if it's even on there or not before even trying it. So if I want to say, for example, like MST filter. So I can say, oh, the VTP's over here too. So 802.1d, 802.1s, I can add that, view, actually not let me view it, let me continue. And you can go through, in this case I want to do iOS, and you can see which versions support MST. So this is actually pretty good because instead of, I mean, I don't even know all these different, models and trains, and, I'm still kind of learning as I go with this stuff too, but, I mean, one good thing is before you try to implement a new image, make sure that you don't, of course, get rid of old features that you may or may not use, or one popular one that I know is SSH. So make sure you get like the K9 image, which gives you that SSH feature. Because when I first started doing networking and I was trying to enable SSH on a switch, or I think on a router or whatever it was, it didn't have that command in there. And I'm looking at myself. I spent like a good 30 minutes Googling stuff, and I'm like, why? The book is telling me I should be able to enable SSH, but I'm not seeing it in the switch. The reason was because I had the wrong image in there. So this is a pretty good tool to use. And like I said, not just for spanning tree, but just in general. So like I said, with all different flavors of spanning tree that we do have, this may or may not become helpful for you to make sure if you actually have the features in there or not. Okay. All right, so the toolkit here. So I like to call these the nerd knobs, or the different ways that we could also, aside from modifying the timers and modifying who's going to be the root or secondary root bridge for our spanning tree topology. A bunch of different features here, which, I mean, you guys tell me. I mean, have you, where do you guys work at? Aside from probably PoreFast, do you guys use any of these other features here for spanning tree to tinker with your topology? Okay, cool, Jeffrey. Which ones do you use, and why? I guess. And if you have a mic, feel free to turn your mic on. PoreFast, yeah, PoreFast is pretty popular. And UDLD, is that for fiber or? Yeah. Actually, one of the slides I have for UDLD, they seem to be pretty much synonymous, or they, peanut butter and jelly effect with fiber. The switches of it, and just out of curiosity, Jeff, what switches are you running for that UDLD and uplink fast? Okay, nice. Cool. Well, we have two 3560s here, so hopefully we'll get there here for tonight. We'll demo that out a little bit. How about anybody else? Anybody else uses anything aside from PoreFast at their jobs, or ever seen in production? Nope. All right. Well, the reason I asked is because generally, most of the time, I always see PoreFast enabled going down to your PCs or printers or whatever. But all these other features here, I don't really see too much. So, once again, going back to the whole, it's not that we're not smart. It's just that we don't see it all the time, and we just forget. So, one of the reasons I put this meetup here together was, one, to kind of review it for myself, and two, we could all review it together because it looks like we really don't use a lot of these too often. And depending if you go on the test or not, or even for job interviews. I mean, one of the most annoying things for job interviews, they like to ask you these questions sometimes, and sometimes I always want to tell the guys, like, hey, like, we don't really use these too often. I mean, unless they use it in their environment, or they try to be slick to be like, oh, what is BP? Difference between BPDU guard and filter. Every once in a while, you may get questions like that, so it's just helpful to know, just to kind of review it a little bit, and just kind of lab it up a little bit too. So, all right, so let's go top down off the list with our toolkit here. So port fast. So this is pretty much something that we learned back in NA, meant for your edge ports, or basically pointing to the end user. So this is going to be like your printer, your PC, your laptop. Basically, I'm not expecting any trunks to be forming on the other end. So the idea behind this is that if I'm going to transition instantly to the forwarding state. So I'm not going to go by going through the learning and listening, all those kind of states. The port is, I'm basically hardcoding that port to be, hey, you know what? I trust that you're going to be not a switch, so I'll instantly put you into the forwarding state. So one interesting thing that I want, and of course, one of the things is if I hear BPDU, I'll shut myself down according to the white paper here, the tech notes here. One thing that I did also, and actually one thing that you guys should do also as well when you guys are studying and whatnot, definitely just do a quick Google search. So for example, if you want to know more about port fast, or it doesn't have to be Spanish, but any kind of Cisco technology, just type into Google, just type in port fast Cisco, or OSPF Cisco, or whatever it is, and just take a look at the first page, and just right click, opening a new tab, and just read up on different opinions or different ways of explaining the technology. So, like I said, sometimes Cisco is a little dry. It's a white paper. Maybe I suck. Maybe you don't like the way that I explain things. Get it from somebody else. Get it from Humphrey. Get it from another meetup group. Get it from someone else in the meetup group here. Or go to a forum. And there's plenty. There's 1,001 ways to explain the same thing. So that's one of the tips that I use when I'm trying to learn something, or take a look at a technology from a different angle, is just look at other people's ways of explaining things, and usually somebody clicks, or somebody helps you understand something better. So usually I kind of start off with the white paper, because they're pretty usually the first tips or the first hits that come up when you type in, for example, like Cisco port fast, and hit enter on Google. So this one in particular, using port fast and other commands to fix workstation sharp connectivity delays. So Cisco's way to fix a workstation because nowadays PCs boot up like in 30 seconds or whatever it is, And with spanning tree, of course, you have that 30 to 60-second delay. So one of the solutions that Cisco made was having port fast. So here you can take a look at the table of contents. You can look at the different models, how to configure it. As you can see here, we can do it on our 4500s, our 6500s, but we're looking here more for our lab here. We got 2950s and 3560s. So let's take a look at this section here. And to get your little introduction here, so I'm not going to go through this here. I'll copy this link into the chat window here so you guys can read that up later. But basically, the way I will configure this is on a port by port basis. This is not a global command. And the command's pretty simple. Spanning tree port fast. I mean, I'm pretty sure we've done this 1,000 times before when we were doing CCNA, but let's try it. And more importantly, what I want to do is, according to the books and the white papers, they say that port fast should shut itself down if it hears a BPDU. So I'm curious to see what happens. So beforehand, let me take a look at what I got right now on that port. And right now I'm on my PoE switch, and nothing is really, all I did was change up the cost of that link, which isn't really going to affect anything with spanning tree. So Let's change that up to switch. Oh, not switchboard. Spanning tree. Okay, I got a bunch of options here. Little hint for the future. We got our filter and guards. But Portfast is the one I want to take a look at right now. So. And going further, I can say disable this guy, disable the Portfast on this interface. So if you want a hard code to disable that, you can do that, and you can enable Portfast on a trunk too, which will be interesting actually. Maybe in a future Switch meetup, I'll put together some like weird scenarios or something and just try these guys out. But we see the caret symbol there, so we're just gonna hit enter. And as we remember from Jeremy's CBTs, you get this long little warning that Portfast should only be enabled on basically to an edge device. You don't want to connect it to any kind of another switch because you may cause loops. So now the thing is, where's my PoE? Where's my topology here? Port 1 is going up to the root bridge here. So technically I should be receiving, for the 2950, I should be receiving DTP frames. Or, I mean, I connected to another switch, so that could be a bad thing. So let me do a show CDP neighbor. Port 1 is connected to that 2950. So let me see what happened. Let me show in status. Now, I didn't do anything. It automatically negotiated itself to be a trunk. So right now it's connected. Now, let me take a look at the other end, because I want to see if I can get that, My thing is, my thing with these meetups is, of course, a lot of times we know the theory, but I want to see what happens when we, don't do what the book says us not to do, or at least prove what the book says is right, So let's go to 2950, and let's put this port 1 here. Let's put him as, like, dynamic desirable or something to see if we can trigger some DTP frames to hit this Portfast port over here, because that's, the book says that technically that port should at least be turned off or go into a down state. So that is P5. Sometimes you gotta do the line. Okay, here we go. Okay, so right now I got nothing on there. I'll show in trunk. So it looks like it's already set to desirable. Let's hard code it. Pro mode trunk. This may yell at me saying, okay, good, it hasn't. Alright, so let me jump back to my PoE switch, P3. Show IP in B. Ah, wait a minute. I got excited for a second. It was the VLAN 1. Alright, so it's still set to an up and up state. Let's see here. That's not what I want. Show run. Okay, so shut the Portfast. Let's change up the topology and see if I can trigger some spanning tree to kind of recalculate and see if that will cause it to go. Actually, even better. Let me unplug that cable and plug it back in on port number 1. So let me this link between these two switches. Let me unplug it and let me see if I get anything. Let me just do a show logging real quick to see if we missed any logs. Actually, that's a good idea too. We can even do a no shut. Let's try that. Okay, so it's listening right now. Which it really shouldn't be because we put Portfast in there, right? So according to the book says that it should go straight into forwarding, right? So why? It shouldn't be going through those states at all. Says port fast. I don't think this had anything to do with it, but just out of curiosity, let me get rid of that. Yeah. Let's do that one more time. According to the white paper, according to the book here, let me do port fast. Okay, Cisco added the port fast feature. This feature spanning tree port assumes that the port is not part of a loop and immediately moves into the forwarding state and does not go through the blocking, listening, or learning states. This command does not turn off STP and makes STP skip a few initial steps on the selected port. So according to the book, it's saying that's the case. Jeffrey here is saying if it is the root, it wouldn't it always be the des. Oh, yeah, you're right. Maybe I'm doing it on the wrong one because the PoE switch is the root bridge. So that probably would be the case. Let's try it on a different one. But then again, according to Cisco, it's saying that it should not even be going through that listening and learning state. And we did see it go through that listening and learning state, regardless of it being the root or not. You know, so according to the CVTs we saw, you know, that's what we were told back when, right, guys? I mean, I set the shutdown, so let's do no shut. Okay, set to up. Yeah, he's listening, he's learning. It's going through the states, guys, but we just saw from Cisco, he said he shouldn't be. But let's take Jeremy's suggestion. Let's go on a non. Let's go to a regular switch, not a root bridge, and see if that's the case. So let's go to the 2950. He is P5. And let's take a look at what we got right now. Oh, line 5. Okay, so set to on. So I believe I hard coded the trunking on this one, on 01, which I did. So let's try it on the other end here. Let's put port fast on this port. Spanning tree, port fast. We get that nice warning. Okay, so port 1 is set to the root role, and it's forwarding. Cost of 19, so this is everything was familiar here, nothing out of the ordinary. So let's shut that port down. And even before I do that, let me do a line console because I don't want to miss anything here. Let's do a shut. Okay. And do show span. Okay, so I shut the port down on the 2950. Port 1 has been completely removed from the spanning tree topology. Let's turn it back on. Okay, set it up. And he's still listening and learning. Yep. He's still going through the states. I mean, according to documentation, that shouldn't be the case. They're Strip port more strong. Spanning tree port fast. So I don't know, guys. Either we're doing something wrong on this end, or which is probably the case. Maybe we are doing something wrong. But then again, I mean, this is port fast. I mean, there's not much that we can do to break it. You know. Let's try. Anything in the logs that we may have missed? No. Let me try this. Let me try moving the cable out. See if that does anything. Just out of curiosity. Alright, let's take a look at spanning tree again. We should be getting the same similar output. We got designate, that's fine. Do we enable BPDU guard? I don't think so, but we can check. Let's do a show spanning tree summary. BPDU guard is disabled by default, so it looks like no. And totals was like another one that we could try out. Now the only thing it seems here, ether channel, blah blah. Switches into PVST mode. Actually, did we change up the spanning tree mode for one of the guys here? Let me, because this is PVST mode. He's on the IEEE, which is the PVST plus. So let's jump to the PoE switch. He is P3. Let's make sure we got them both talking the same language here. The same version, because that might mess something up. Yippee, what happened? Huh? Eat? No, that's fine, baby. Oh, shit, my thing crashed. Well, all right, sorry guys, my Adobe here crashed. Okay, let's take a look at the show spanning tree totals summary. Switches in PVST mode. So it looks like we're talking the same language here between these two switches. Yeah, PVST. We're not in rapid, so that's not the case. Let's take a look at the BPDU guard on this end. And BPDU guard and filter is disabled. Oh, you guys can't see my screen? Okay, hold on a second here. Let me do this again. Hold on a second, guys. Okay, here we go. Okay, how about now, guys? Can you see the screen? Okay, beautiful. Okay, so we took a look at the PoE switch. We did show spanning tree summary. So we established two things right now, guys. Actually, three things. So both port 1 and port 1 on the 2950 and the 30 and the PoE switch, we're talking, they both are hard-coded to be port fast. We're talking the same flavor of spanning tree. They're both set to PVST. So we probably, I think on the 3560 we changed it to rapid. And we're not using any BPDU guard or filter. They both being disabled on both ends. But once again, we're still in that problem where Port fast is not doing what it said it was supposed to be doing. Let's see what else. Let me take a look at that. I don't think it'll make a difference, but let's go to the 3560 P4. Whoops. I'll do a show spanning tree summary here. Okay, so this one's talking also PVST. Maybe I didn't change it then. Here, show spanning tree. IEEE. Okay, so everyone's talking the same. Okay. How about the guys who are using packet tracer? And then Cornelius, you said you were using packet tracer. Did you get any different output when you were using port fast on your end? This is a long document here, but let's take a look at the config here. Copy run start, replication, show spanning tree interface. Let's me do that. I'm just trying to try some different commands here that we can use to see if we can get that to go straight into forwarding. Let's jump back to the PoE switch. Spanning tree interface. Okay, so that doesn't really tell us too much information here. It just tells us everything's forwarding. Yeah, we're trying to make it go straight to forwarding because according to the book, port fast should take us straight to forwarding. And we are not seeing that right now. Yeah, that was actually gonna be my next thing. I was actually gonna get like a crappy laptop that I have here and directly connect it and try that instead. So maybe I'm guessing it could be maybe I guess built-in self-defense mechanism or something. It won't go into forwarding if you push it to another switch, which is I actually want to see a loop happen. Let's do this again. Show 1. Let's make sure we got that port in the right VLAN. Let's make sure we're on. Because when we did put that port fast message there, it did say, you know, warning, don't connect this to any switches or whatnot, but it looks like according to these tests, it will still go through those states. So one thing I can do here, let me try to connect let me get a laptop. Let me put it into port 2 on this PoE switch. So let me put him into, yeah, he's already in VLAN 1 already. So let me do spanning tree port fast. Yeah, we get that message again. So port fast. Okay, so it's up and up right now. So let me plug something in right now and see what I get. Okay, so show spanning for 1. This is actually interesting here. So notice I did plug a laptop in there, and instead of showing P2P, point to point, I'm seeing edge. Which, if I go back here, meant for edge ports. So that's interesting. It looks like it went straight into forwarding when we put a laptop in there. But what I did want to see though is if I put a switch in there, it doesn't react the same way, you know. So let me unplug that. Let me do show spanning tree again. He no longer exists. And I'll specify VLAN 1 for this. Yeah, and it's going straight into forwarding. So it looks like, let me plug him into let me disconnect the laptop, let me plug it into a different port on another switch that I have powered on right now and see if I still get this edge part here. No, so I plugged into a different switch and it's going back to point type and it's going through the listening states here. So it looks like we can't force it. It wants, you know, I guess it detects that, you know, it's not a switch, it's a laptop. It'll turn into an edge port. But I'm kind of a little disappointed. I was hoping to see, you know, it be an edge port and go up instantly and cause a loop. We could disable spanning tree on the interfaces. Spanning tree interfaces. I think there is a command for that. Is it UDLD? Where is he? FlexLink, I think it was. Which I'm jumping pretty much really ahead with the FlexLink command, but we could disable. Jeff, how would we go ahead and disable that spanning tree for the port? Because the only thing I could think of is if we enable FlexLink on that port. Enable BPDU filter on both sides. Okay, so let's give that a shot. Let me do that. And turn them into access ports. All right. Let's see if we can do that. All right, so Pee-wee, let's go here. My thing is, I'm thinking because it's set as a trunk, it just knows that the other side is it's a switch. That's why it's not going in. Even though we're hard coding port fast, it's not going straight into forwarding. So that sounds like a good idea. Let's put it into access. And before we do BPDU filter on both ends, let's just say access and see if that satisfies, you know, gives us the results we're looking for. Okay, access port fast, so that's good. And let's go to the 2950. Let's get rid of the trunk. All right. Okay, so let's shut down that port. Okay, we see that, and let's bring them back online and see if we get that edge status. If not, then we're gonna do we'll do BPDU filter like Jeff said here. and see if that works. Scanning tree. Actually, I want to do this first. Do VLAN 1 because I want to get it pretty instant. I want to see if I actually catch it in time. So spanning tree. Filter. Enable, I think it is. Yeah, enable. Alright, so let's jump to the PoE. PoE is 3. Let's jump to the 2950 because I got that command in there. Well, it's not a trunk anymore, so I wouldn't imagine to see it here, but let's shut it down either way. Let's see what happens. It looks like I already had it shut down already. Alright, so let's bring it back up. Here you go. It went straight into forwarding. So that actually brings up a good question now. So what is BPDU filter anyway? And where is my slide here? Per interface, because we did a per interface, ignores BPDUs and does not send BPDUs. This could cause a loop. And I have a... I didn't put the reference down here. I usually put on the bottom here the links where I got it from the white paper from. Let's see. Are the lights going crazy? You said port 1, right? It's just blinking. It's blinking like any of the other ports I have on there, so I'm not seeing them going crazy like the CBT said they would. But good. This is good though because we want to get this set as an edge port. All right. Let's do a 0-1 again. Because we hardcode that thing to be an axis. So BPDU filter I'm ignoring, and I'm not even sending BPDUs at this point. So technically I can actually put that as a trunk, and maybe that'll make the lights go crazy. Because then it's kind of like a double negative only. I'm not sending BPDUs, but I'm going to be sending DTP frames. So let's put them back as a trunk. Where is my? Here we go. The light seemed fine. Yeah, and it looks like once I changed that back to a trunk, I lost my edge status. So technically, we should really go to, where am I? This isn't right then. I'll shut myself down. It looks like you have to be an access switch or an access port in order to use the use PortFast, which I'll have to play more with, but that's actually good to note. So this may not be the case. So let's say port must be in access mode to enable. Let's say that for now. So what happens if I hear BPDU on a PortFast enabled port? Looks like, I don't know guys, the consensus is it looks like it doesn't do anything. We saw it just going through the listening and learning states, Nothing really changed. The only time we finally did see that change was when we hard-coded the port-to-b access and we put BTU filter on. Because once we changed it back to a trunk, the port, we lost that edge status, and it just changed to a regular, listening and learning. And the ports, lights weren't going crazy. So that's good to know. So I would have to test this out later on. So that's probably going to be for a future meetup. We'll see. And let me go to my commands over here, guys. So spanning tree port fast. Of course, this is so. Long story short, we got two ways that we can enable port fast. One was the way that we were doing. We were enabling it per interface. But there's a way that we could actually enable this on the whole entire switch as a whole, which could be a good test. We can run that at a later time. But just through the regular config mode, we would just say spanning tree port fast default. And as we go through the different toolkits, it's going to be pretty similar. Either enable on the interface level and default for the whole switch as a whole. So we got two different ways of putting port fast on our switch, and a couple ways that we could verify that, aside from just doing like a regular spanning tree, show spanning tree or show run. We got a command here, show spanning tree interface 01 port fast. So let's try that. Show spanning tree 01 question mark. Inconsistency. It's kind of good to know, but we'll play that for later. Port fast. And it says port fast is disabled on 01. That's because we changed that to a trunk. So let's change it back to an access switch or an access mode. Let's do show spanning tree. I got my edge status back in there, as you can see here. Let's issue that command again. So now, I'm seeing over here VLAN 1 is enabled now when I issued this verification command that I have in here. Whereas before, when it was set as a trunk, it was set to disabled. So that's kind of good to know right there. We also have another verification command here, show spanning tree int 01. Let's see what that gives us. And that's pretty much kind of like a mini pipe command, I guess you could say. Instead of saying show spanning tree and giving us this whole output over here, I just want to see. I wonder what that's about. And I just want to see that particular line for port 1. And we said that's the edge port because we hardcode that guy to be port fast. And something happened here. This port just went down for some reason. Let's do a show in status. Port 2 says unconnected. Not connected, but that's weird because I'm looking at my chart right now and I'm physically looking at it. The 2950 has port 2 going to the 3560. So either my cable got loose or spanning tree did something. So let's see, show IP in B. Did my cable go loose? Hold on a second. It's kind of weird. Let me see what I got here. Nothing. Something happened to port 2 here. Let me do show. I think there's a command where you can see the error disabled states. Show spanning tree. Try inconsistent ports. That's not the one I'm looking for, but no. There's a verification command here. BPDU guard. So maybe the BPDU filter did something over here. Let's see, recovery. Everything's set to disabled. Yeah, it did show in status, but it didn't say errors. The stat here should be disabled, not connected. So that's kind of weird. Let's try to get rid of that BPDU filter enable. Now we kind of pretty much proved the point of, you know, getting that port to be an edge port. And I'll change it back to be a trunk. Let me try port 3. Let me just pull them out 2 and put them in 3. I don't think my port went bad. That's kind of weird if that's the case. Three became a trunk automatically. I just moved it out of port 2, put port 3. We'll do show spanning. See what we got for port 3. It's learning. It's doing its states and everything. So I put it back in port 2. It's disappeared again. So let me go to my 3560 and see what we got configured on that end. P4. And that's port 3. Or port 2. Yeah. Because the light's also off on the 3560 end. Here it is. Error disabled. So it looks like we were on the right track. We were doing the right commands, but we were not on the right switch. So this is kind of actually interesting, guys. So error disable looks like it's not on the same end, meaning like, I would think kind of theory would say is like, you know what, if I see error disabled on this port number 2, I should see it on the other end too, right? It looks like it isn't. So why do we go on error disabled? My thing is with the BPDU filter, I think something happened. I think Jorge said here, Spain should BPDU guard enabled, puts a port on error disabled upon receiving any BPDU. So we heard one from the 35, where's my chart? We heard one from port 2 off of 3560. And it put it into an error disable state, which that's why it killed, put that point error disabled. That's kind of weird though, because I'm doing I got nothing configured on this end. But on the 2950, I do have something configured on port 2, but I think we removed it. Hold on, let's go back to port, let's go back to P5. Yeah, nothing's there. It's completely empty. Set it down. Let's jump back to 3560. Clear line 4. Let's show error disabled detect. So everything's enabled here. What does flat values give us? I don't know if that really helps us. Recovery. That's weird. Because I don't think we, I mean, guys, correct me if I'm wrong, but I don't think we touched the 3560 for this. So, I mean, usually when I see this, the quickest way to fix this is just do a shut and no shut. Okay, I did a no shut. The port's coming back up. Okay, it's back to being a trunk. And it's back in my spanning tree topology. Set the block. It's back up. So I'm not sure why. Yeah, it's still up. So I'm not sure because as far as we saw, guys, we were just playing with BPDU filter on this link on the left side here. I don't think we touched anything on port 2 here, so I don't know why that caused the flap, but I mean, regardless, I mean, you know, we're all here to learn, guys. So one thing to take a note at here is if you're seeing kind of weird behavior like this, look at all the ports and as Jorge and Jeffrey mentioned, do your see if any ports are in error disabled. And the quickest way to get, you know, that out of error disabled, and look at this. I'm on my 3560 here. The loop detected. Loopback error detected, putting error disabled. Ether. Is that ether channel or am I just reading that wrong? But yeah, like I was saying, guys, quickest way that you can do to fix that up is put in a shut and then no shut to bring it back up. But as we just saw just now, something just happened. I think it's safe to say we'll have a part 3. But yeah, let's see what happened here. Error loopback detected. I don't think I have any spanning tree here. Ether channels here show. Because I don't think I saved any of my config from last time. Yeah, I don't have any port channels here. So one thing that I do, guys, when I see this, I'll copy this and put a quick Google search here. Let's see what I get for possible reasons for this. Looks like keep alive packet, some help. Okay, port 2. Port 2 is actually connected to the port 2 of the 2950. And as of right now, the root bridge is the 3560 PoE. Let me see here. Actually, guys, can you just give me a second, guys? Hold on. Let's see. Resolution. I mentioned this in system. Keep alive. The wrong sent. The problem occurs because the keep alive packet is looped back to the port that sent the keep alive. Keep this up for the switches and prevent loops in the network. Keep alives are enabled by default. Issue the no keep alive in order to disable keep alives, which I don't know if we want to do that. But that's a good workaround if we do want to do that. Let's see what tech exams gives us. I don't know about you guys. I mean, right or wrong, is this the real thing that we do? We're at work and we see an issue we don't know. Don't we just Google it? So I mean, one of the reasons I kind of put these kind of off the cuff labs. Granted, it does take us longer to do, but what I really like about it is the fact that we actually get to see like these weird these weird scenarios and ways we could troubleshoot it. So Let's see. Is there a port channel on the 2950? No, there's no port channel on 2950, Jeff. It's a brand new. It's pretty much a brand new switch out of the box, but we can verify that. As you can see, we don't have any port channels here. Oh. So let's actually do that workaround where the guy said use a no keep alive. Let's try that on the 3560 because that's the one that's giving us that weird loop error. If I take a look at P5, short run into, I got bare bones config. I got nothing on there. So, but if I do a show run trunk, right now that light is off, so I shouldn't even see it there. Let me jump to that 3560. Show run 2. I got nothing there either. But what was that workaround that we saw? Something about a keep alive. I'm going to have to look more into this later on. But I wanted to disable the keep alive. Disable keep alive prevents error disablement of the interface, but does not remove the loop. Actually, Jeff, we probably should see the lights going crazy now if we do no keep alive. And it's going to keep, according to this, it's not going to prevent the loop. Now, is that a global command or interface? Probably. And let's bring that interface up, down, shut, no shut. Okay, so I'm getting an amber light right now, so it's probably doing its listening, learning, and everything looked like it was okay. Port 2's blocking right now. So I'm wondering, if it's blocking, then why is it... What happened to my port 3? Okay, so my port 3 just disappeared from... Oh, actually, no, wrong one. I'm looking at different VLAN. Okay, everything's back to normal. We disabled keep alive on the on 02. One thing too, guys, when you're jumping from device to device, always do a show logging, or when you start doing troubleshooting, you can clear out the log, or even better, like if your company has the money and they can afford like a syslog server or something, so you can kind of save these little messages. Because if not, you may have missed this message here. And it looks like we even saw this message earlier, but because I was not on the switch at the time, I didn't see it. So we were kind of going like a little wild goose chase for a while. But usually when this kind of stuff happens, though, you would manually like pull that cable out or shut that interface down, and then kind of research and find out what was the cause of that, after the fact. Because I mean, I don't think it's a good idea either to like do a no keep alive here, because technically, so quote unquote, we have a loop going on. The other thing to think of is because we enable BPDU guard or a filter on this segment here, it may be affecting the rest of the layer 2 topology here. So let's go back and disable that, and because we were just using that to prove the port fast. The whole story we're trying to do here, we're just trying to prove the fact that if we can get port fast on for the switch, which we kind of saw that it just works if we set it for access and for laptops. So let's go back to the PoE in 2950 and put that back to default. And that should hopefully clear this up here. And then once we get this whole looping cleared up here, we're gonna let's kill it for the night, so we don't go too long here. P5. All right, so we said 1. So let's kill the port fast. And also one good thing to note as well too, guys, when you guys are putting, let's say we were at a company, right? Let's say you're at your job and something like this happens to your job. Right now we're just shooting commands on the fly. We're googling stuff, probably not too far away from what you would do if you were at work yourself. So one thing that I like to normally do when I get into these situations is get a paper and pen and just write down what commands did you do at what time. So I usually kind of keep like a little chart and say like, okay, at 9:15 p.m. I put port fast on 01. So if I get you get like kind of after like a few hours of troubleshooting something, you kind of you're kind of saying to yourself, what the hell did I do the past 20 minutes? I don't know what commands I put in, and then you're kind of scrambling to say, oh, what did I do, and then it just doesn't make you look too good for your boss or for your work. So one of the things that I like to do is kind of keep a track sheet of what commands I did, so I can just retrace my steps and undo or redo the commands, so I can kind of get the similar output, if you know what I mean. So that's what I'm going to do here. We know that we did our we hard-coded trunk, which I don't think is going to be the problem, but the port fast we still have there, so let's get rid of him. And we'll go to the PoE and do the same, which he is P3. And we actually have BPDU enabled there too as well, which I believe BPDU filters should only be enabled like facing down to the access layer, not facing to other. Oh, actually, you know what? Now this kind of makes maybe a little sense. I'm thinking maybe BPDUs were coming. I mean, BPDUs are going, as in a circle here. So if one piece of the switches are ignoring it, we're causing a loop basically, or we're getting that error inconsistent state on the 3560, which I'm kind of weird. I don't know why 3560 detected that, but for some reason by playing with BPDU filter on this link here, we affected this side of the network. But either way, let's get rid of it. So you know that, and he's still an access port, so let's make him a trunk. We'll just hardcode that. All right, we'll just say no access. That should put it back to dynamic desirable. And no port fast. Okay, so it's back to his bare bones. Oh. Okay, so auto negotiate on port 1. That's what I'm looking for. We do show spanning. Port 1's back. It's doing its listening, learning, as you can see here. It's being a DP port. It's going downstream because we said the PoE switches the route, as we saw up here. Let's jump back to our 3560. I'll do my show in status. Let's see if he's still error disabled. Let me do show log too. Let's see if I missed anything while we were away on the other two switches over there. Okay, so it happened twice. I don't see it happening again. Error disabled. Error disabled. We did a no shut twice, so that is good there. And did we turn back on the keep alives? No. All right, let's put that back on. And let's see if we get any more error consistent. Should go through listening, learning, or whatever it does. No, blocking. I'll do a clear log too, just so that we get a fresh log to look at. Port 2 still up, the green light's still on. Showing status. Still up. So I think it's safe to say that us trying to prove the point on this end affected the right side of our layer 2 topology here, which is kind of interesting. I would think it would be the opposite. If anything, we would see that error consistent on this side, but for whatever reason, we saw it on the right side. Probably because we're throwing BPDUs. All the switches are advertising BPDUs anyway. So that's kind of interesting. So I guess the takeaway from this, guys, is look at your error disabled. Do your show in status on all the switches if you're having some kind of weird looping issues. And take a look at the logs, because things may have happened if you're not at the switch at the time. So hopefully you have a big enough buffer size to capture all those logs, or even better, if you have some kind of a syslog server. That's even better. So, okay, so any other commands we could do here? Showing port fast. I think we did this already here. No Spanish tree available for 0. Oh, that's right, I don't have anything on there. Okay, so port fast is disabled on port 2 for all our spanning tree instances, which is fine because we don't want port fast on anybody right now. So I think we're pretty much done with port fast. I mean, you guys have any questions? Port fast, anything you want to try out? Any, buttons you want to press before we wrap up for the night here? No? Okay. Perfect. All right, guys. Anyway, let's wrap up here for the night. Unfortunately, we didn't even get to the first hobby. We just did one. We just played with one of the different toolkits that we can play with PortFast with Spanning Tree here. Where's my little toolkit here? So we just for tonight we did this guy here, PortFast. He's done. We played a little bit with BPDU filter, but I'm not going to cross him out just yet because we didn't really. We kind of spilled into him by mistake. We weren't really planning on focusing about him yet. But I guess the takeaway here is, guys, yes, granted, we're kind of taking a while to go through all these, but the good thing is that what we do here is, one, we're working with real gear. Hopefully you guys have real gear on your end too and kind of doing something similar. You guys maybe might get some other kind of crazy stuff on your end that you guys can share with us. And two, I mean, like I said, correct me if I'm wrong, but if the same thing would happen if we were at work, I'm pretty sure we would probably do the same steps that I was just doing just now. We're going through all the switches, doing a bunch of different show commands, shutting ports down, shutting ports up, Googling stuff. So it's good to kind of see this ahead of time. I mean, there's no pressure here. We're all, friends, colleagues. I mean, our job is not at risk right here. So, put the time in now, put the effort in now. And the good thing is, too, time, when it comes for interview time, and it comes time for, for even better when something like this happens at work, you're kind of familiar. You've seen this before already. And that's kind of what I'm gearing the meetups here for tonight, or for any of the tech meetups that I'm trying to put together. I don't want to just regurgitate what you guys see in a CBT or read in a book. I mean, there's plenty of YouTube videos that can do that for us, But I'd rather give you guys something different that you haven't seen before, and we can troubleshoot off the fly. Because, it's just real world, guys. It's what would happen in the real world anyway. So, Jeffrey, I really appreciate the participation from you, man. And all you guys, putting in the, throwing in, try this, try that. So, I think it's pretty nice. So I mean, we'll probably pick up uh, maybe the second we could do it. I don't think I have anything scheduled for the second. Let me take a look at the calendar. Yeah, so I guess we'll continue with our Sunday nights. We'll do another one. Hopefully, we'll finish the rest of these these cool toolkits here. We spent a good time. We probably spent like a good chunk of the meetup just getting familiar with spanning tree. So hopefully that that helped you guys. Um, and I think next week we'll do these guys here, knock them out, and we'll finish up with the first hop stuff. So all right, guys. So I'm gonna also actually let me kill my recording.